Hey everyone, it's time to cover lesson 42 and today's topic is exponential functions. So as you see, that's my definition of exponential function. So as you see, this a is called base and this x number is called exponent, everyone. Let me write it clearly. X should be exponent here, and then a is going to be the base of this function. So first part of this lesson is we're going to evaluate exponential functions. But that is something we have done before already. Nothing has changed, same thing. So to find f of -1, take this, plug in here. So it should be 2 to the negative first power. So which means 1/2. Okay. You can just go to calculator and see this, right? Or you can just f of 3. Take 3, go here. So it should be 2 to the third power, okay? But answer shouldn't be 6, right? Please don't do that. It's not 2 times 3. 2 to the third power. 2 times 2 times 2, which is going to be 8, everyone. That's how you find it. Those are those are bad numbers to work with. So let's say f of 2 and I want to try f of 5. And make sure you find those, everyone. They're kinds of super easy questions. Alright, f of 2, f of 5. So let's move on. Right. So here, exponential function. And there are some rules here to graph, and you can see domain and range as you see here. But I don't go this way. So I always go to Desmos, graph, and make the conclusions, all right? So if you have here, a to the x power. If you have a is bigger than 1, this is how it looks like, right? But if you see 1/2 to the x power, if you see that a is less than 1, it's going to look like this. But again, we don't need to memorize this stuff. We can just graph this on Desmos and see it. We can just graph it on Desmos and see the conclusion. That's all what we do. That's all what I do. That's what I choose to do. Again, there are some rules here. If you have if your base is bigger than 1, like 2, 3, 10, it's going to be increasing. But if you have those numbers less than 1, like 1/2, 1/3, 1/10, they are going to be decreasing. Again, you can memorize this or just graph and see. So have a look at this one. Graph this and domain and range. So to graph this, let's go to Desmos again, right? So we're here 1/5 to the x power, right? Power x, right? If I graph this, that's what I see here. Okay. If I zoom in, I want you to see that it won't touch the x-axis. It has been getting super close and close, but it's not going to touch. So let me screen shadow this. Here we are. And it over here. That's my graph of it. And domain and range. So domain should be what? Domain was my x numbers, right? So it should be, domain was as you see, those positive numbers will hit my graph. Also those negative numbers initially will hit the graph as well anyway. So it's going to be all real numbers, negative infinity to positive infinity. But the range should be my y values, right? So as you see, my y values is going to be starting here, right? It's going to be all those positive numbers. There is no way to cover those negative numbers. We can say all positive numbers, or we can say 0 to infinity. All right. Again, you don't need to memorize those previous stuff. Just graph and see. That's how I do it. And here, graph each function. Show the graph for comparison. Keep the main range. So let's say 2 to the x power. 2 to the. I'm gonna do A and you're gonna do B, everyone. 2 to the x power. 2. That's my initial function, right? And then I'm told what? Negative 2 to the x power. Here we are. If, oops, no parentheses over here. Here we are. So here we are. We got the function. We got two graphs, right? So as you see, if we take a screenshot of this, so we're gonna see what? Over here, show the graph comparison. So it's going to be what? Reflected over, so the new one, this function is reflected over x-axis. Let me type over here. Reflected over the x-axis. That's all. Just graph and see. And lastly, it says what? Give domain and range. So that's my function, right? Negative 2 to the x power, which is, let me color it. This one, right? So domain should be what? Again, domain should be, it's gonna touch those negative numbers. It will touch those positive, so it's going to be all real numbers again. But range this time, this graph has been going down. There is no way to include those positive numbers. So it's going to be covering negative numbers. I'm gonna say 0 to negative infinity. Or let's go with this one, negative 0, negative infinity to 0. Okay, let's go with this one. I mean, this is much more accurate, the bottom one, not this one. Okay, so range should be negative infinity all the way up to 0. Or we can say only all negative numbers. Okay, so that's the first part. So second part, we're gonna work with exponential equations. That's why I bring up a couple of equations. We're gonna work with those, and then I'm gonna move to hard equations. All right, but I want to show you the basics first. Let's say we got this exponential equation. We're gonna solve this. What's the x value here? So to see x value, we're gonna do this. Like, to work with exponential function, the first criteria is we should be having same bases. All right, we should write them in same bases. I'm gonna do this. 2x plus 5th power equals. How can I write this in base of 2? So it should be 2 to the 4th power. Okay, because 2 times 2 times 2 times 2 is 16. So if we have same bases, we're gonna say that we should be having same exponents. So x plus 5 should be equal to 4. So if we subtract 5 from both sides, we will get x equals negative 1. So that's my answer. That's x equals negative 1. Alright folks, that's how we solve it. Let me show you one more example. Let's say we got this one. So let's write the first one, 5 to the power. But how can I write this one in terms of 5? So it should be 5 to the 3rd power, because 5 times 5 times 5 is 125. So as you've seen, again, we got same bases, which means we should be having same exponents. 2x minus 3 should be equal to 3. And solve for x, get x alone there. I'm gonna do plus 3 plus 3. These two cancel each other. 6, so divide both sides by 2. So x should be equal to 3 here. So that's my answer there. That's how we solve them. So next, how do we deal with negative exponents? All right. So to solve them, this is how we do it. Like, if you see negative exponent, you always do 1 over. Negative exponent, put 1 over. Negative exponent, 1 over. And then you go down. And there is no more negative number anymore, because you do 1 over. Like same as over here, 1 over 4 to the 3rd power. There is no more negative anymore. And here, 5 to the 1st power. So it should be 1 over 3 squared was 9. That's my answer. 3 to the negative second power equals 1 over 9. That's my answer. And this one should be equal to 1 over 4 times 4 times 4 should be 64. And lastly, 5 to the first power should be just 5. Okay, that's how we deal with negative exponents. So let's have a look at this one. So as you've seen, we have a 1/3 here. So 1/3 means 3 to the negative first power to the power x equals to 81. Right? So if you have an exponent, so like you should multiply them. So it should be 3 to the negative x power equals to. But again, as I mentioned earlier, we should be having same bases to work with them. So 81 means 3 to the fourth power. Oh, I'm so glad to see that we got same bases, which means same exponent. So negative x equals 4, so x should be equal to negative 4, which is my final answer. That's how we solve it. And let me show you this one. So first one, 2 to the power x plus 4. 8, how can I write this in terms of 2? So like, I know that 8 is what? 2 to the third power what equals to 8. So I'm gonna write this in 8. 2 to the third power to the power what? X minus 6. So it should be what? 2x plus 4. So if you are having like double exponent, you just multiply them. That's how it works. So it should be 3x minus 6. So it should be 3x minus 18 there. So my exponent should be 3x minus 18. I'm super glad to see that we got same basis, which means the top part should be same now. X plus 4 equals to 3x minus 18. And we solve for x basically. Basic algebra, minus x, 4 equals 2x minus 18, plus 18, plus 18, 2x equals 22, so divided by 2, so x equals 11, and that's my answer here. Okay, so look, my basic goal is get them same bases, and the rest is kind of super easy. If you're having same bases, top should be same as well. So at this point, guys, make sure you try those are your examples, and on the next slide you will see the answers. Please have a try first and then check your answer over here. All right, and then that's my last examples, and I'm going to finish this lesson. So x to the power what? 4 over 3 equals 81. I'm gonna do this, like I'm looking for x, right? I had to get rid of that one, so I gotta get another exponent to get rid of this one. Like, remember earlier, if you have another exponent here, we multiply them. So like if I go with reciprocal, like 3, 4, and I gotta be fair, whatever I do here, do the same thing over here. Like I want you to see that if I multiply those, they will cancel each other. So I'm gonna get x alone here. Now 81 to the power 3 over 4. Okay. At this point, you can go calculator, or you can do it this way. I know that 81 was what? 3 to the 4th power to the power 3 over 4. So as I mentioned, if you have a double exponents, just multiply them. 4 times 3, 12, divided by 4 is just 3. 3 to the 3rd power, so it's going to be 27. So x equals 27. So that's my answer. And then I want you to have a try those examples, everyone, and then you can see the answers over here. But please have a try first. Thank you for listening. Have a good one.